Okay, so good morning. For this video, I want you to assume that you are a grade 7 students in a mathematics class, and our topic is all about sets. Okay, so good morning class.
Good morning, sir.
Okay, so Miss Secretary, is there anybody who is absent today?
No, sir.
Okay, so since nobody is absent today, let's give a hand for everybody. Okay, so at this moment of time, I am going to paste a picture here on the board. So here is the picture, and I am going to paste it on the board. Okay, so what can you say about the picture? Okay, so as you can see, there are put inside a rectangle, and it is being grouped. No, so the group A. This is for the group A. Then for the group A, we have here trees, aside from the one who is different. Then we also have group B, and for group B, of course, as you can see, there is also one picture, or yes, that is different from the group. Did you see it? Okay, now, so from here, what can you see? What did you see on picture A? Very good. So picture A has all of it in all of the elements that are in picture A are threes, except for one, and that one is the pineapple. So very good. How about for picture B, Erika? Okay. So for picture B, all of the fruits that are on picture B are strawberries, except for one, and that is the pineapple also. So, but as you can see, for picture A and for picture B, they have a common. What is the common for picture A and for picture B for each group? Very good. They both have a one pineapple in each group. Very good. So now that's what we are going to discuss today, because our topic for today is all about sets. Okay. So is there anybody who has an idea about sets? Okay, that's fine. If you don't have any, I am going to discuss it to you, by the way. Anyway. Okay, so when we say sets, in mathematics, set is a well-defined collection of objects. Sets are named and represented using a capital letter. So as you can see here on the board, as what I have showed you, as you can see a big letter. So it has to be presented in big letter, huh? So, and then, in the set theory, the elements of a set comprises can be any kind of thing. It could be people, it could be letters of the alphabet, numbers, shapes, variables, and etc. Okay? Very good. So now, I have here an example of sets. Okay, so here is an example of a set. So the representation of sets using a Venn diagram. So set A is equal to, the elements of set A is 1, 2, and 3. Now for the elements, it should be put inside the bracket. Did you get it? It should be put inside the bracket, this one, the curly bracket. And then for set B, we have the elements 3, 5, 7. Now, do you have any idea why is the element 3 for set A and the element 3 for set B has been put at the center? You don't have any idea? Okay, that's fine. It's okay. So it is being put here at the center. It is because element 3 and 3 of the set B are common or is common. No, that is the common for the two sets. Now you are going to put here at the center of the Venn diagram the common of the both sets. Okay, so since we only have 3, but if ever, could it be possible that the two sets or the sets has more than one common? Yes, it is possible. It is possible that there are more than one common for the sets. So here we have here 3. Let's just stick to the example that I have given to you. So now this one is the set A, this circle. Then the second circle here is the elements of set B. So as you can see, number 3 is at the center because it is the common of the two sets. Okay, did you get it? Now, the second one, let's say for the set A. So for the set A, only what are you going to do is you are just going to put it in here, the remaining elements of the set. Okay, so since 3 has been put here at the center, you are going to just put the remaining elements, and that is 1 and 2. So that is the remaining element. Did you get it? Okay, so the next one for the set B, since 3 also is common for set A and set B, and it has been put at the center already, so we are just going to take away number 3, or we're going to disregard this one and copy the remaining elements and put it on this side, no, for the set B. So it is being put in here. That's 5 and 7. Okay, that is one of the ways on how are you going to solve it. Now, as you can see, we have here 1, 2, 3, 5, 7. How do you call that? 1, 2, 3, 5, and 7 is the union set. When the teacher asks you for the union, if somebody asks you for the union of sets, you're going to just write everything in here. What's in here? 1, 2, 3, 5, and 7. Now, are you going to, how many times are you going to write number 3 since they are common? No, there are common elements of set A and set B. You are only going to write it once. Okay, so do you get it now? Okay, since you already have an idea about that one, I am going to give you an activity. Okay, so here is the activity that you are going to do. So, for your activity, you are going to make it individually. Okay? So, I have give you here the set A, the elements of set A and set B is already given. So, what are you going to do is to to put all the elements that belongs to set A on this side and set B for this side, and the common element should also be put in here at the center. And that what I have discussed to you a while ago. That's what you are going to do, and you are going to do it individually. Okay? Okay. You may start now. You can use your just write it on a piece of paper. Thank you. Okay, so the both of you got the correct answer, and this one is a great job. So I just want to ask you a question: if how did you get this one?
By listening to your discussion attentively, sir.
Very good. So I can really say that you really are listening to my discussion attentively because you all got the correct answer. So here, based on your answer, the common of the two sets is the element E. So we just put it here at the center. And then for element A, based on your answer again, that's C, D, F and G. And then for set B, that's H, I, J, and L. Very good. So now, by the way, I just want to ask you a question. What is, what do you call this one? How do you call this one? The common of the two elements.
That is the intersection of the sets, sir.
Very good. So that is the intersection of the set. And now, so this time, what you are going to do is, since we are done with your activity and it seems like you already know it, what you are going to do this time is you are going to have your assignment. Okay, now, so for your assignment, you are going to search about the complement of the set. Okay, do you get me? You're going to search about the complement of the set, and you are going to present it to me next meeting. Okay, so everybody stand for our prayer.
Let us put ourselves in the presence of the Lord as we all say, and Father, the Son, the Holy Spirit, and Lord, thank you for this wonderful day, Lord. And thank you for the discussions that we have learned from our teacher. And thank you, Lord, guide us always in the name of Jesus. Amen. In the name of the Father, the Son, and the Holy Spirit. Amen.
Okay, so thank you and God bless. Then see you next meeting. Okay, so the theory demonstrated is the connectionism theory of Edward Thorndike, in which Thorndike's views of learning suggest that it is consists of associations between stimuli and responses.